Hello, and welcome to today's video where I will be discussing rationalising denominators. So we started having a look at this in my last video where we looked at examples such as 7 over root 8. So I'm going to very quickly recap how to do those before moving on to how to rationalise the denominators in fractions such as 7 over 1 plus root 2. So just to recap, we have 7 over root 8. To rationalise the denominator, we can't change the fraction because we need the value to be the same, but what we can do is multiply by something that equals 1. For example, root 8 over root 8. So anything divided by itself equals 1, so that does equal 1, so we're not changing the value. And then you just get 7 root 8 over 8. And then as we saw, this can be simplified because root 8 equals 2 root 2, so we get 7 times 2 root 2 on the top, 8, which is 14 root 2 over 8. And then we can factor out a 2 from the top and the bottom to just leave us with 7 root 2 over 4. Similarly, I also showed that you could actually start by writing it as 7 over 2 root 2. And then because we only have a root 2 as our irrational part now, we can just multiply by root 2 over root 2, which then equals 7 root 2 over, well, it's 2 times root 2, which is just 4. And as we can see, these two get the same result whichever way round we do it. So, very quickly, two more examples of those. Rationalise 8 over root 18 and 5 over root 27. Feel free to pause the video if you need more time. But okay, so for 8 over root 18, we established you could do 8 over root 18 times root 18 over root 18 equals 8 root 18 over 18. Now we can immediately factor out a 2 from the top and bottom here to leave us with 4 root 18 over 9, but root 18 is 3 root 2. So we actually get that it's 12 root 2 over 9, and then we can factor out a 3 from the numerator and denominator here to leave us with 4 root 2 over 3. Similarly, we could have done 8 over 3 root 2 from the start, just multiply by root 2 over root 2, and we get 8 root 2 over 3 times 2, which is 6. And then we can factor out a 2 from the numerator and the denominator to leave 4 root 2 over 3. And as you can see, we get the same answer each time. Now, I won't show you both ways for 5 over root 27, but 5 over root 27 is 5 over 3 root 3. So we multiply by root 3 over root 3, which just equals 5 root 3 over 9. Okay, so now we move on to fractions which have a rational and irrational sort of sum in the denominator. For example, 7 over 1 plus root 2. And at the end of this, we want to have all of our irrationals, all of our surds, on the numerator, so we don't want any on the denominator. But you could try multiplying by root 2 over root 2, so if we try that quickly, the top becomes 7 root 2, and the bottom, well, the root 2 times root 2 just becomes 2, but the 1 times root 2 stays as a irrational, so we get root 2 plus 2. That hasn't helped. So, what if instead we tried multiplying by 1 plus root 2? Now, the top, we do 7 times 1 is just 7 plus 7 root 2. 7 times root 2 gets you the 7 root 2. Then, for the bottom, you might not know how to multiply this out. I don't know. If you haven't seen the FOIL method before, what you can effectively do is you can multiply it out using the grid method. So for example, if you had something like 11 times 13, using the grid method, you actually work out 10 plus 1 times 10 plus 3. So here, we're going to do exactly the same, except we're going to do 1 plus root 2 times 1 plus root 2. So we've got 1, root 2, 1 and root 2 there. Now 1 times 1 is 1, 1 times root 2 is root 2, 1 times root 2 is still root 2, and root 2 times root 2 is 2. And then, as you know, we add all those up, and we get 3 plus 2 root 2. See, if you have seen the FOIL method, then you can do it much quicker, but it's not bad to practice. So the 3 plus 2 root 2, it's no use to us. We've still got that irrational on the denominator. What we can multiply by is 1 minus root 2. And this is important because if we then do our grid multiplication for the bottom, we've got 1 root 2 there, and then 1, and then we have to remember to keep the sign. So we write minus root 2 there. Obviously 1 times 1 is 1. 1 times root 2 is root 2. 1 times minus root 2 is still minus root 2. And root 2 times minus root 2 is root 2 times root 2 times minus 1, so it's minus 2. And we add those together, we get 1 minus 2 equals minus 1. Then we've got plus root 2 minus root 2, so the root 2's cancel and we're just left with minus 1. So if we were to work this out, we'd get 7 minus 7 root 2 in the numerator and minus 1 in the denominator. And if you don't like having the minus sign there, you can multiply the top and bottom by minus 1 over minus 1. You'll get 7 root 2 minus 7 over 1, or just 7 root 2 minus 7. This also works if you had something like 5 over 2 minus root 3. You could then multiply by 2 plus root 3 over 2 plus root 3. Again, that's still 1 because it's still something over itself. And then, again, if we grid method here, you get 4, 2 root 3, minus 2 root 3. That's a horrible 3, sorry. And root 3 times minus root 3 is minus 3. Here we get 4 minus 3 equals 1, and the 2 root 3 and minus 2 root 3 cancel, so we're just left with 1. So we find this equals 10 plus 5 root 3 over 1, or just 10 plus 5 root 3. So the general rule is, if your denominator is in the form of a plus root b, you multiply by a minus root b. And if your denominator is in the form a minus root b, you multiply by a plus root b. Now in this case, it generally is easier to keep your surd as one surd. So if you had something like 5 plus root 8, say, it would be easier to do it as 5 plus root 8 times 5 minus root 8, rather than try and do 5 plus 2 root 2 times 5 minus 2 root 2. Now, it is worth noting that regardless, if you have a plus or minus this symbol, in case you haven't seen it, plus or minus means it could be added or subtracted. A plus or minus root b, you then multiply by a minus plus. Note the difference in symbols basically means that if this is being added, i.e. the top half, then this is being subtracted, and vice versa. If the first one is being subtracted, then the second one is being added. But then the general result is going to be a squared minus b. So in the example here, if we had 5 plus root 8 times 5 minus root 8, the general result is 5 squared minus 8, which equals 25 minus 8, which equals 17. And we can check that. We draw our grid out. 5 root 8, 5 minus root 8. We get 25 there, 5 root 8 there, minus 5 root 8, and minus 8. So we've seen the irrationals cancel, and we just get 25 minus 8, which equals 17, as we saw above. Okay, so your turn. Let's give you 3 problems to work out. First of all, what is 7 plus root 3 times 7 minus root 3? Then rationalise the denominator of 5 over 4 plus root 6, and rationalise the denominator of 11 over 7 minus root 8. There we go. So I'll zoom out a bit. You can see all the problems. Feel free to pause the video if you need a bit more time. And once you're done. So 7 plus root 3 times 7 minus root 3. We've seen it should just equal 7 squared minus 3, which equals 49 minus 3, which equals 46. And again, we can check that using our grid or FOIL if you know it. I'm not assuming you don't, but I don't want to accidentally assume that you do, basically. So we've got 7 root 3, 7 minus root 3, 49, 7 root 3, minus 7 root 3, apologise, and then minus 3, which we know equals 49 minus 3, or 46, as we saw above. I'll make my 4 a bit clearer. Now, rationalising 5 over 4 plus root 6, we're going to be multiplying by 4 minus root 6 over 4 minus root 6. If we do that, we're going to get the top, the numerator, equal to 20 minus 5 root 6. And the denominator we know is going to be 4 squared minus 6, which is 16 minus 6, which equals to 10. And then we can simplify this if we notice the top is still 5 times 4 minus root 6, and the denominator is 5 times 2, and we can factor those 5s out, so we just get 4 minus root 6 over 2. Don't worry if you didn't spot that last bit though. And final example was rationalising the denominator of 11 over 7 minus root 8. So in this case we're going to be multiplying by 7 plus root 8 over 7 plus root 8. Means the numerator becomes 77 plus 11 root 8. And the denominator, we know it's going to be 7 squared minus 8, which is 49 minus 8, which is just 41, and that can't be simplified. So thank you for watching this video. My next video is going to be on standard form, and I will hopefully be transitioning to a regular upload schedule of on Tuesdays. So I will see you next Tuesday.